In the year 100 trillion, there is no night sky, not because it is bright, but because it is empty. The stars have long since burned out, their fuel exhausted, their light extinguished. Galaxies, once vibrant cities of billions of suns, are now dark clusters of cold remnants, black dwarfs, neutron stars, and the silent husks of what once was. The cosmos has cooled to near absolute zero, a temperature so low that even atomic motion slows to a whisper. Space itself continues to stretch, driven by the relentless push of dark energy, pulling every remnant farther apart until each object is alone, invisible to the next. There are no observers, no light, no sound, no time as we understand it, only an endless, featureless void, a universe that has reached its final state. And in that silence, a question lingers, not spoken but implied by the emptiness. Did it all mean anything at all? But rewind 13.8 billion years, and the universe is not silent. It is not cold. It is not empty. It is a single point of infinite heat and density, a singularity beyond comprehension. And then expansion, not an explosion into space, but the birth of space. Time begins. Energy floods into being. In the first 10-36 seconds, the universe inflates exponentially, expanding faster than light, stretching quantum fluctuations into cosmic-scale ripples. These tiny imperfections, smaller than a proton, will one day become the scaffolding of galaxies. Gravity, still nameless, already begins to pull matter toward these invisible seeds. The universe is writing its own blueprint in the dark. For 380,000 years, the cosmos is a blinding fog, a plasma of protons, electrons, and photons, all locked in a chaotic dance. Light cannot travel. The universe is opaque, a glowing prison. Then, as expansion cools the plasma, electrons and protons combine into neutral hydrogen atoms. The fog lifts. Photons, finally free, surge outward in all directions. This is the cosmic microwave background, the first light of the universe, the afterglow of creation. And though we cannot see it with our eyes, we have heard it. In 1965, Arno Penzias and Robert Wilson, tuning a radio antenna at Bell Labs, detected a persistent, uniform hiss. They cleaned the antenna, removed pigeon nests, even scraped off droppings. But the noise remained. It was not interference. It was the voice of the infant universe whispering across time. That faint signal, later mapped by satellites like COBE and Planck, reveals a universe that is flat, uniform, and finely tuned. So precisely balanced that if the density had differed by even 1 part in 1060, galaxies would never have formed. But the universe is not static. In 1929, Edwin Hubble, peering through the Hooker telescope at Mount Wilson, made a discovery that changed everything. He measured the light from distant galaxies and found that their spectra were shifted toward the red, indicating they were moving away from us. And the farther they were, the faster they receded. The universe was expanding. Not only that, it had a beginning. The Big Bang was no longer a hypothesis. It was a fact written in starlight. Hubble sat alone one night, cigarette glowing in the dark, staring through the eyepiece. He had just realized that Andromeda was not a nebula within our galaxy, but a galaxy in its own right, millions of light years away. The universe had just become vastly larger, and he said nothing, just exhaled, watching the smoke curl into the cold air. He had seen beyond the edge of human knowledge, and he knew we are not central, we are not special. We are part of something incomprehensibly vast. Fast forward to the 1990s. 2 teams of astronomers, led by Saul Perlmutter, Brian Schmidt, and Adam Rees, are studying distant type Ia supernovae, the explosive deaths of white dwarf stars. These supernovae are standard candles. Their brightness is predictable, allowing scientists to measure cosmic distances. They expected to see the expansion of the universe slowing down, pulled back by gravity. Instead, they found the opposite. The supernovae were dimmer than expected. The universe was not slowing, it was accelerating. Something was pushing space apart. They called it dark energy. It makes up 68 of the universe, yet we do not know what it is. We only know that it is winning the cosmic battle against gravity. Imagine a galaxy 50 billion years from now. A civilization looks up. They see their own stars, yes. But the other galaxies, Andromeda, the Virgo cluster, the great spirals and ellipticals, are gone, not destroyed, not exploded, just unreachable. The space between galaxies expands faster than light can cross it. Each galaxy becomes an island universe, isolated in an ever-growing void. The cosmic web, the vast network of filaments and clusters stretching across billions of light years, dissolves. The universe forgets its history. The evidence of the Big Bang fades. The cosmic microwave background stretches into undetectability. Future civilizations may look out and believe their galaxy is the only one that ever existed. They would have no way of knowing about the grand story. The clues will be gone. We are living in a privileged era, the last era in which the universe's history is still visible. And yet here, now, in this fleeting moment, we are surrounded by relics of a richer past. The James Webb Space Telescope peers into the distant universe and sees galaxies that should not exist. Massive, structured, fully formed just 300 million years after the Big Bang. How did they assemble so quickly? Simulations struggle to explain them. Perhaps early black holes helped seed their growth. Or perhaps dark matter clumped more densely than we thought. Or maybe the first stars, monstrous, metal-free giants hundreds of times the mass of the sun, burned so fiercely they forged galaxies in their wake. These stars lived fast and died young, exploding as supernovae that seeded the cosmos with carbon, oxygen, iron, the building blocks of planets of life. We are made of stardust, but not just any stardust. We are the residue of stars that lived and died in an era that is already ending. The era of star formation is winding down. Observations show that the peak of stellar birth was around 10 billion years ago. Since then, galaxies have been running out of gas. The cold molecular clouds that collapse into stars are being depleted. Some galaxies have already gone quiet, their spiral arms frozen, their star nurseries extinguished. Even the Milky Way will one day cease forming stars. The interstellar medium will thin. The last red dwarfs will flicker on for trillions of years, but they will be dim, cold, lonely. And what of black holes? The Event Horizon Telescope gave us the first image of a shadow. The silhouette of a supermassive black hole in Mate 7, 55 million light-years away. A monster with the mass of 6.5 billion suns, warping spacetime into a vortex of no return. Black holes are not just destroyers, they are architects. Their jets and outflows regulate star formation. They heat gas, prevent collapse, shape galaxies. But in the far future, when stars are gone, black holes will dominate. They will orbit one another in decaying spirals, emitting gravitational waves. Ripples in spacetime first detected by LIGO in 2015, when two black holes merged a billion years ago, sending a tremor through the universe that reached Earth in a fraction of a second. Over eons, even these black holes will evaporate. Stephen Hawking predicted that black holes slowly leak energy through quantum effects at their edges. Hawking radiation. For a stellar mass black hole, this process takes 1067 years. For the largest, 10100. In those unimaginable timescales, the universe becomes a graveyard of fading particles. Photons stretch to wavelengths longer than the observable universe. Matter itself may decay. Protons, once thought eternal, might unravel. The cosmos becomes a thin soup of radiation and subatomic debris. And then perhaps the final state. A near-perfect vacuum, no events, no change, no observers. This is the heat death of the universe. Not a bang, not a crunch, but a whimper. A universe that has reached thermodynamic equilibrium. Maximum entropy. Total stillness. Some theories suggest that in such a state, quantum fluctuations might, over infinite time, give rise to a new Big Bang, a quantum resurrection of the cosmos, a Boltzmann universe popping into being from nothingness. But who would remember us? Who would know that once, for a brief moment, stars shone, planets formed, and minds looked up and wondered? Back in the present, we stand on a pale blue dot, orbiting an average star in a spiral arm of a galaxy among trillions. We have built telescopes that see back to the edge of time. We have detected the hum of gravitational waves. We have measured the expansion of space with lasers bounced off the moon. In 1969, Apollo astronauts left retroreflectors on the lunar surface. Today, astronomers fire lasers at them and measure the return pulse. The moon is drifting away 3.8 centimeters per year, pushed by Earth's tides. A tiny motion. But it speaks of a universe in motion, always changing, always evolving. There is a story, perhaps apocryphal, of a young astronomer in the 1930s sitting in a cold observatory in Pasadena. Her name was Vera Rubin. She was measuring the rotation of galaxies, and something was wrong. Stars at the edges of galaxies were moving just as fast as those near the center. According to gravity, they should have been slower. Something invisible was holding them in place. She called it dark matter, but the scientific community dismissed her. For years, her data was ignored. It wasn't until decades later that the world realized 85% of the matter in the universe is invisible. We walk through it. We are held by it, but we cannot see it. Vera Rubin died in 2016, never awarded a Nobel Prize. But her discovery reshaped our understanding of the cosmos. Today, the Atacama Large Millimeter Array, ALMA, stares at the cold universe. It sees the birth of stars in dusty clouds, the formation of planets in swirling disks. It has detected complex organic molecules in interstellar space, alcohols, sugars, the precursors of life. These molecules drift between stars, waiting. Perhaps on some world they will one day assemble into something that looks up and asks, "Why are we here?" But even that may not last. The sun will expand into a red giant in 5 billion years, engulfing Earth. Before that, increasing solar luminosity will boil the oceans. Life, if it survives, will be driven underground or into the outer solar system. But eventually, even that refuge will fail. The universe does not care, it simply is. And yet, there is beauty in this impermanence, the fact that we can see the past in the light of distant galaxies, that we can reconstruct the history of the cosmos from the faintest signals, that for a brief moment in cosmic time, consciousness emerged, that we can stand beneath a starry sky and feel awe, that we can tell stories about the universe, even as it fades. In 2019, the Event Horizon Telescope released the first image of a black hole. It was not just a scientific triumph, it was a cultural one. People around the world stared at that orange ring and felt something. A connection, a wonder, a recognition that we are part of something greater, but future civilizations may never see such a thing. As galaxies drift apart, the evidence of the Big Bang will vanish. No CMB, no distant quasars, no colliding galaxies. A civilization born in the far future might look out and conclude that their galaxy is the only one that ever existed. They would have no way of knowing about the grand cosmic story. The clues will be gone. We are living in a privileged era, the last era in which the universe's history is still visible. So when we look up, we are not just seeing stars. We are seeing a vanishing past, a universe that is already forgetting itself. Galaxies like cities, now dark and abandoned. Supernovae like fireworks, now silent. The cosmic web, once vibrant, now unraveling. And yet, for now, the stars are still there. The Milky Way still arcs across the sky. The Andromeda Galaxy is still approaching, destined to collide with us in 4 billion years, not in violence, but in slow, gravitational embrace. New stars will form from the chaos. Life, perhaps, will find a way. But one day all of this will be gone, not with a catastrophe, but with a whisper. The universe will not end with despair. It will end with peace, with stillness, with the quiet dignity of something that existed, changed, and passed on. And if there is meaning in it all, perhaps it is this, that for a brief moment the universe became aware of itself, through us, through our questions, through our wonder. We are the universe reflecting upon its own beauty, its own transience. So yes, was the universe born to fade? Perhaps, but in its fading it gave rise to light, to structure, to life, to consciousness, to stories. And as long as we remember, the universe is not yet gone.